Hello, my scienticians. How are you doing tonight? Let's talk about some light. All right, so we're learning about photosynthesis now. Photosynthesis is how plants use light, which is the photo part, to make new molecules, which is the synthesis part. Make sure you understand what those two words mean, because photo will come in useful later, as will synthesis. Photosynthesis is an enzyme-mediated reaction, set of reactions, which means it uses enzymes to get all of its stuff done. Now, what's most important to understand is, and that's the point of these notes here, is that plants use pigment molecules to collect that light and use it for a particular reason. In this case, the pigment molecules are used in a process called photolysis. Photolysis. Photo means light. Lysis means to break apart. So it's going to use light to break something apart. And in this case, it's going to use light to break water apart. And the hydrogens are going to be used later on, but the oxygens aren't used. And that's where the O2 comes from that plants give off. The water is broken apart, and light energy is used to do that, and that's where we get the oxygen we breathe. Now, I didn't write a lot right there. I just wrote a couple of arrows. It might be really helpful for you to back this recording up just a little bit and add a couple of notes to what these arrows mean and what photolysis means. But what color are plants? Plants are green. Why are plants green? Because they reflect green light from their leaves. What reflects the green light? A pigment molecule. What pigment are we talking about? So plant cells have lots of pigment molecules. Lots of pigment molecules. The one that you're the most familiar with, the example we're going to talk about is chlorophyll. Well, chlorophyll is a particular kind of pigment molecule and has a couple versions of it. We're going to talk about chlorophyll A. The first part of your drawing quiz that you're all going to have to do is called an absorption spectrum. We're going to make a quick graph on the y-axis is going to be absorption. And on the x-axis is going to be the wavelength of light. Okay? Now, remember way back from your middle school science that there's lots of different kinds of radiation. Visible light is one form of radiation that comes from the sun. And all of these different things have different wavelengths. Okay? And we are going to be talking about the range of 400 nanometers all the way up to 700 nanometers. So our unit for this graph is nanometers. Absorption has its own units. We're just going to worry about just as a percent. So this is an absorption spectrum. We're going to call this an absorption spectrum. And this one is specific to chlorophyll A. Now, chlorophyll looks green, which means it reflects green light. So where does green sit in here? Well, do you remember Roy G. Biv? Roy G. Biv. R and Roy is for red. O and Y are orange and yellow. Then we have green. Then we have blue, indigo, and violet. So if you take this and if you flip this around so that it's Vib G. Yor, you'll get how everything sits on our absorption spectrum, because violet light has a wavelength of 400 nanometers and red light has a wavelength of about 700 nanometers. So you can see how this spectrum here kind of fits with this right here. All right, so let's get to our graph. So how this works is that the chlorophyll doesn't absorb light underneath the visible light spectrum. So your graph should start kind of low. It should start kind of low, down here. in this area because it's not really absorbing that light. Now, remember, this is the violet end of the spectrum, so the kind of radiation that exists all the way down here under 400 is below violet, which we call ultraviolet light. All right, let's get back to our graph. Your graph should really peak high. You should have a high percentage of absorption in the blue area, in the violet and blue range. Think about our grow light that I showed you all today in class when I blinded you all. There was only red and blue lights on there, and that's because plants absorb red and blue light. Specifically, chlorophyll A absorbs red and blue light very, very well. Very well. Down here in the middle, this is our green area. We should have very low absorption, and this should make total sense to you because plants look green because they're not absorbing that green light, they're reflecting that green light. Then, as we get here towards the yellow, orange, red area, we should have another peak here, and then it should drop off. So after the 700 nanometers, this doesn't become visible light anymore, so there's no way for the plants to absorb it. Particularly this pigment only absorbs wavelengths of light in the 400 to 550 range, and then in the 600 to 700 range. So it only absorbs light in that violet, indigo, blue, and yellow, orange, red area. So what's above red? Well, think about it. If below violet was ultraviolet, what do you think is above red? Oh my gosh, you're so smart. It is infrared. You're right. Anyway, this is the graph that shows us that you understand how chlorophyll A is really good at absorbing red, orange, yellow light and blue, indigo, violet light and doesn't absorb green light. And once again, what does it use this light for? It uses this light for photolysis, to get the hydrogen that it'll use later on for something else in photosynthesis, ends up producing oxygen as a byproduct, which we need. All right, that's the first part of your drawing quiz for this section. The second part will come later. Have a good one.